Green's theorem is nothing but transformation between line integral and double integral. The double integral is nothing but surface integral. First, we can take the statement of the theorem. What is the surface or what is the region is bounded in which plane and how to calculate the line integral value and surface integral value. If capital R is a closed region in xy plane bounded by a simple closed curve C and if capital M and capital N are continuous functions, of x and y having continuous derivatives in capital R. Continuous derivatives in capital R. Then the closed curve over C, that is line integral, Mdx+Ndy is equal to double integral over region capital R dou n by dou x minus dou m by dou y into dx dy. Here the statement can be calculated. Here m is the f vector, that f vector equal to mi plus nj. Here m and n are both are functions of x and y variable with continuous and derivable functions. And we know that r vector is the position vector, that is xi plus yj. We are taking in xy plane means it is the two dimension derivative on both sides. Dr vector means dxi plus dyj. Then f dot dr, it is the closed curve, that is the work done, mdx plus ndy. We can take over the curve C, work done along the curve C. Then here dou n by dou x minus dou m by dou y into dx dy. How to calculate that one means we can take the curl f vector. The curl f vector means f vector is nothing but mi plus nj. It is I, j, k. Curl is nothing but del, dou by dou x, dou by dou y, dou by dou z. F vector is m, I, nj, k component is 0. Then taking the determinant, it is equal to I into 0 minus dou n by dou z, but derivative with respect to z is 0. Why? Because m and n both are functions of x and y variable. If we can take the j means dou by dou x of 0 is 0 minus dou by dou z of m1 is nothing but it will be 0. Why? Because m is the function of x and y. Here k into plus minus plus dou n by dou x minus dou m by dou y. It is the curl f vector. If the curl f vector means that is del cross f vector, we can take surface integral f dot n ds, that is curl f vector dot n ds. Here we can take curl f vector ds means ds is nothing but it is in xy plane, that is dx dy by modulus of n dot k. Here n dot k means this is the unit normal vector. We can take n vector is the k vector along the y because it is the xy plane means the xy plane normal vector in the xy plane the normal vector is the along the z axis. So here n vector is equal to k vector. So curl f vector dot n vector means k dot k equal to 1. So it is nothing but dou n by dou x minus dou m by dou y into ds is nothing but dx dy by k dot k equal to 1. So it is the over r. That is nothing but integral over cf dot dr is equal to surface integral curl f vector dot n vector ds. That is the Green's theorem. The Green's theorem is nothing but transformation of the line integral to surface integral or double integral. Okay. How to get this relation between the line to double integral, that is single integral to double integral means we can take it is the along the over C means we can take the work done force that is F dot dr. It is this over region means that is the curl F vector dot n vector ds. Okay, from that relation only we are getting this integral over C Mdx plus Ndy is equal to double integral over R dou n by dou x minus dou m by dou y into dx dy. You have to remember the statement of the Green's theorem. From the Green's theorem, we get idea and we remember the relation of the line to surface integral and the given function is comparing with the any one of the integral. From that only we get the m and n functions, then calculate what they are asking. If compute or determine means we use the Green's theorem, or verify the Green's theorem means we can find out the along the line integral value and in the double integral over the region we can calculate both values. If both values are same, then that is verified the Green's theorem. Okay.
Yes, ma'am.
Verify first problem. Verify Green's theorem in plane for integral over C 3x square minus 8y square into dx plus 4y minus 6xy into dy, where C is the region bounded by y equal to root x and y equal to x square. First, we can take the region in that which is the lower bound and closed curve. From the closed curve only we can calculate the line integral value and double integral value. If both are equal, then the Green's theorem can be verified. First, we can take the given line integral. What is given that integral over C 3x square minus 8y square into dx plus 4y minus 6xy into dy is equal to comparing with integral over C mdx plus ndy. Here m is equal to 3x square minus 8y square, n is equal to 4y minus 6xy. Okay. First, we can draw the diagram how to get the parabolas. These two are parabola equations. One is y equal to x square. The region bounded by y equal to root x and y equal to x square. Here y equal to root x can be squaring on both sides. One is y square equal to x and another one is y equal to x square. Here y equal to it is x plane, it is y axis, it is x axis. Y equal to x square means this is the general form of the parabola equation, it is y equal to x square. And how to we get this is the y equal to x square, and the another curve is the y equal to root x, means we can take the values of here x values -2, -1, 0, 1, 2. Here y equal to x square means it's 4, 1, 0, 1, 4. See here 1, 0, it is 1, it is 2. This is -1, this is -2. It's 1, it's 2, 3, suppose it's 4. It is equal to -1, -2, -3, -4. This is also we can take -3. It is -4. This is 3. This is 4. Here x equal to -2 means it is -2. The value is positive, it is 4. -1 means this is equal to +1. And 0, 0, it is equal to 1. And for 2, it is the 4. We can draw the parabola like this. And another one is we can take y is equal to -2, -1, 0, 1, 2. X equal to y square. It's 4, 1, 0, 1, 4. Y equal to -2 means it is -2. The value is x is +4. -1 means 1. It is 0. It's 1. It's 4. For y equal to 2, this is 4. We are getting like this. The intersecting point is 1 comma 1. Okay, this is the y equal to x square curve. It is the y equal to root x curve. That is nothing but this is the y equal to root x. Upper curve is the y equal to root x. Lower curve is y equal to x square. Okay, here the limits of for double integral, the meeting points are 0 comma 0 and 1 comma 1. So x and y limits for the double integral, x and y limits are 0 to 1. Why? Because the intersecting points are 0 and 0 and 1 comma 1. Here we can calculate the m is differentiating with respect to y, n is differentiating with respect to x. For the double integration, it's n equal to 4y minus 6xy. M is differentiating with respect to y is it's 0 minus 8 into 2y. It is equal to minus 16y. N is differentiating with respect to x. It is 0 minus 6 into 1 into y. It is equal to minus 6y. And subtract from one to another, dou n by dou x minus dou m by dou y is equal to minus 6y minus of minus 16y is equal to minus 6y plus 16y is equal to 10y. So we can take the double integral over r dou n by dou x minus dou m by dou y into dx dy is equal to integral x limits from 0 to 1. Okay, and y limits, we can take the curve. What is the curve? That is not we are taking that. The curves we can take the x and y. The upper limit, lower limit, the lower curve is x square, upper curve is root x. So we can take it is the y equal to x square lower curve from 0 to along the curve y equal to x square from 1 1 to y equal to root x. So we can take the limits of y. X limits are 0 to 1 and y limits are x square to root x. Okay. So it is lower curve is x square, upper curve is root x, and dou n by dou x minus dou m by dou y value is 10y dx dy. It is equal to integral x equal to 0 to 1. 10 integral of y dy is y square by 2. Limits from x square to x, 2 1s are 2 5s are into dx. It is equal to integral x equal to 0 to 1. 5 upper limit is x square root x means root x into root x x minus lower limit is x square whole square is x to the power of 4 into dx. It is equal to 5 is a constant. Integral x dx is x square by 2 minus integral x to the power of 4. Integration is x to the power of 5 by 5. Limits from 0 to 1. It is equal to 5 into it is 1 by 2 minus 1 by 5 minus 0. So taking the LCM, 5 into 10 is the LCM, 5 minus 2 is equal to 3 by 5 ones are 5 twos are 3 by 2. Therefore, RHS is equal to double integral over R dou n by dou x minus dou m by dou y into dx dy is equal to 3 by 2. Next, we can calculate the LHS, that is the line integral. Okay. In this, the line, again we can take the diagram, that is it is the y equal to x square curve, it is y equal to root x, it is y equal to root x, it is y equal to x square curve. This is the origin 0 comma 0, it is the intersecting point 1 comma 1. Okay, here first we can take the curve C1, let it be O, it is A, again O. Okay, O is the closed curve, that is the closed curve C. In these two curves are there, one is the lower curve, another one is the upper curve, C1 and C2. The lower curve is from origin to A point, that is 0 to O, A. The another one is the line integral from A to 0. Okay. Here we can take 0 to A is the along the curve y equal to x square. A to 0 is the along the curve y equal to root x. Okay. In this we can take substitution of y equal to x square and dy is equal to 2x dx, and limits we can take x limits from 0 to 1 for another integral for c to 1 to 0. We remember that one. Here Mdx plus Ndy, it is integral over c is equal to integral over c1 Mdx plus Ndy plus integral over C2 Mdx plus Ndy. In C1, y equal to x square, that is the C1 curve. From this, dy is equal to 2x dx and x limits from 0 to 1. Therefore, integral over C1 Mdx plus Ndy is equal to integral over C1 m is equal to 3x square minus 8y square into dx plus n is 4y minus 6xy into dy. It is equal to integral x equal to 0 to 1, 3x square minus 8 into y is nothing but x square whole square into dx plus 4 y is nothing but x square minus 6x into x square dy is nothing but 2x dx. It is equal to integral x equal to 0 to 1. In all terms taking common dx, 3x square minus 8x to the power of 4. Here 4 outside is 2x is there. 4 2s are 8. X square into x cube plus 8x cube minus 6 into 2 minus 12. Here x cube into x to the power of 4. It is equal to integral x equal to 0 to 1 3x square plus 8x cube minus 20x to the power of 4 whole dx. It is equal to 3 x square integration is x cube by 3 plus 8 into x cube integration is x to the power of 4 by 4 minus 20 x to the power of 4 integration is x to the power of 5 by 5. The limits are from 0 to 1. 3 ones are 3 ones are 4 ones are 4 twos are 5 ones are 5 fours are. It is 3 into 1 plus 2 into 1 minus 4 into 1 minus 0. 3 plus 2, 5, 5 minus 4, it is equal to 1. 3 plus 2, 5, 4, okay. We are getting plus 1 or minus 1. Plus 1 only, na?
Going to at the bottom.
Yes, 3 ones are, 3 ones are, it is x cube. X cube is nothing but upper limit is 1. 1 plus 2 is 3, 3 minus 4 is minus 1. Okay. In C1, the line integral over C1 is 1 and we can calculate in C2. In C2, the curve is y equal to root x. From this, dy is equal to 1 by 2 root x dx. Is it clear? 1 by
Yes,
2 x power minus 1 by 2. Next, and x limits from 1 to 0. So integral over C2 Mdx plus Ndy is equal to integral over C2 3x square minus 8y square into dx plus 4y minus 8, sorry, minus 6xy into dy is equal to integral x limits from 1 to 0, 3x square minus 8 y equal to root x, y square is nothing but x into dx plus 4 root x minus 6x root x dy is nothing but 1 by 2 root x dx. Here it is equal to integral x limits from 1 to 0, 3x square minus 8x into dx plus root x is taking common 4 minus 6x into dx by 2 root x. Root x cancel. It is equal to x limits from 1 to 0. dx is taking common. Here 3x square minus 8x. Here 4 means 2 ones are 2 twos are. It's plus 2. 2 ones are 2 threes are. This is minus 3x. It is equal to integral x limits from 1 to 0. 3x square minus 8x minus 3x minus 11x plus 2 into dx. It is equal to integrate with respect to x. X square integration is x cube by 3 minus 11 into x integration is x square by 2 plus 2 into 1 integration is x limits from 1 to 0. The lower limits, upper limits are 0 minus 3 ones are 3 ones are. Upper lower limit is 1, that is 1 cube is 1 minus 11 by 2 plus 2. Substitution of x equal to 1. It is equal to 1 plus 2 is 3 minus 3 plus 11 by 2. Taking LCM 2 minus 6 plus 11 equal to 5 by 2. Therefore, integral closed curve C Mdx plus Ndy is equal to integral over C1 Mdx plus Ndy plus integral over C2 Mdx plus Ndy is equal to minus 1 is this along the curve C1 plus 5 by 2 is the along the curve C2, taking the LCM minus 2 plus 5 by 2 equal to 3 by 2. Therefore, LHS is equal to integral closed curve C Mdx plus Ndy is equal to 3 by 2. It is equal to double integral over region capital R dou n by dou x minus dou m by dou y into dx dy is equal to RHS. Therefore, integral over C Mdx plus Ndy is equal to double integral over R dou n by dou x minus dou m by dou y into dx dy. Hence, the Green's theorem is verified. Okay. The second problem is verify Green's theorem for integral over C 3x square minus 8y square into dx plus 4y minus 6xy into dy, where C is the region bounded by x equal to 0, y equal to 0 and x plus y equal to 1. See here, this is the y equal to, it is the y equal to 0, it is the x equal to 0, x-axis. X-axis means the y coordinate is 0. On the y-axis means x coordinates are 0 and x plus y equal to 1. That is nothing but we can take x limits, x values are minus 2, minus 1, 0, 1, 2. What is the y? Y equal to 1 minus x. Then x is taking to left side. It will be the line of x plus y is equal to 1. From this, it is equal to 1 minus into minus plus 2. It's 3. 1 minus into minus plus 1. It's 2. 1 plus 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 2 is minus 1. So here we can take 0, 1, 2, 3. It's 1, 2, 3. And this is minus 1, minus 2. Here for minus 2, this is the 3. For minus 1, it's 2. For 0, it is 1. For 1, the for x equal to 0, y is 1. For x equal to 1, y is 0. For y equal to x equal to 2, It's a minus 1.
minus 1.
What we are getting, this is a straight line. So
Straight line.
this is the x plus y is equal to 1. It is the y equal to 0. This is C1. This is C2. X plus y equal to 0. And it is C3. In for C3, x coordinate is equal to 0. Okay. Here the limits are here 1 comma 0. This is 0 comma 1. Okay. We get the triangle. This is the triangle. It is the 0 comma 0. We can take origin. It is a equal to 1 comma 0. It is b equal to 0 comma 1. This is C1. It is C2. It is C3. For C1, y coordinate is 0. For C2, x plus y equal to 1. For C3, x is equal to 0. Here, verify Green's theorem. Verify Green's theorem means we can calculate the line integral over C, Mdx plus Ndy. It is equal to integral over C1 plus integral over C2 plus integral over C3. Three curves are there along the lines. This is the LHS part. The RHS part is double integral over region dou n by dou x minus dou m by dou y into dx dy. We can calculate this one. Okay. This is the idea how to calculate. Okay. Now,
Yes, ma'am.
from this, what they have given? They are given that integral over c 3x square minus 8y square into dx plus 4y minus 6xy into dy. It is comparing with integral over c mdx plus ndy is equal ndy. In this, m is equal to 3x square minus 8y square. N is equal to 4y minus 6xy. Here first, either we can go through the line integral or we can go through the over region capital R. That is our wish only. Okay. Here,
Yes, ma'am.
first we can calculate the double integral. For the double integral, what are the limits? That is the main thing. Here, first find out the dou m by dou y. It is equal to minus 8 to the 16y. Dou n by dou x. It is equal to minus 6y. Dou n by dou x minus dou m by dou y. Already we did in the previous problem only. Minus 6y minus into minus plus 16y is equal to 10y. Here RHS is equal to double integral over R dou n by dou x minus dou m by dou y into dx dy. In this we want the limits. The x limits from on the x-axis, the values are varies from 0 to 1 and y limits from converted into x 0 to 1 minus x. Why? Because x plus y is equal to 1. From this, y is equal to 1 minus x. They have given x equal to 0, y equal to 0 and x plus y equal to 1. From that, y limits are 0 to 1 minus x, x limits are 0 to 1. It is equal to integral x limits from 0 to 1, y limits from 0 to 1 minus x, and it is equal to 10y dx dy. 10 is a constant right outside, integral x equal to 0 to 1. Y integration is y square by 2, limits from 0 to 1 minus x dx. It is equal to 10 into integral x limits from 0 to 1 minus x whole square by 2, 2 ones are 2 fives are into dx. It is equal to 5 integral x limits from 0 to 1 a minus b whole square a square plus b square minus 2ab into dx. Now we can integrate with respect to x. One integration is x plus x square integration is x cube by 3 minus x integration is x square by 2 limits from 0 to 1 2 ones are 2 ones are. It is equal to 5 into 1 plus 1 by 3 minus 1 plus 1 minus 1 get cancelled. The value is equal to 5 by 3. Okay. So therefore double integral over r dou n by dou x minus dou m by dou y into dx dy is equal to 5 by 3 is the value. Next we can calculate the LHS. For that, integral over C1, or first we can take, again here we can take the O, A, B, it is 1 comma 0, y equal to 0, it is x equal to 0, this is x plus y equal to 1. So case 1, in C1, the curve along x-axis, so y equal to 0, from this dy equal to 0, and x limits from 0 to 1. So integral over C1 Mdx plus Ndy is equal to integral x limits from 0 to 1. M values are 3, 3x square minus 8 into 0. First we can take the integral over C 3x square minus 8y square into dx plus 4y minus 6xy into dy. It is equal to integral x limits from 0 to 1, 3x square minus 0 into dx. It's 0 equal to 3 is a constant right outside. X square integration is x cube by 3. Limits from 0 to 1. 3 get cancelled. 1 minus 0. It is equal to 1. It is the equation 1. Next, in C2, the curve along x plus y is equal to 1. Okay. From this, y is equal to 1 minus x. So dy is equal to minus dx. Here the values are 0 to 1, 1 to 0 here. And here also we can reduce to x variable, means y can be written as 1 minus and x limits from 0 to 1. So integral over C2 Mdx plus Ndy is equal to integral over C2, here it is C1, 3x square minus 8y square into dx plus 4y minus 8x, 6xy into dy. It is equal to integral x equal to 1 to 0, 3x square minus 8 into y square means 1 minus x whole square into dx plus 4 minus 6x into y is 1 minus x into minus dx. It is equal to x limits from 1 to 0, 3x square minus 8 into 1 minus x whole square, 1 minus 2x plus x square, plus multiply, plus into minus minus, it is minus 4 ones are 4 minus 4x minus 6x minus into minus plus 6x square whole dx. It is equal to integral x equal to 1 to 0, 3x square minus 8 minus into minus plus 16x minus 8x square. Here minus 4, this is minus 10x minus into minus plus 10x minus 6x square whole dx. It is equal to integral x limits from 1 to 0, 6x square minus 8x square, that is minus 5 minus 6 minus 11x square, 16 plus 16x plus 10x plus 26x minus 12 into dx. It is equal to minus 11 x square integration is x cube by 3 plus 26 into x integration is x square by 2 minus 12x limits from 0 to 1 to 0, limits from 1 to 0. Here 0 only, minus into minus plus 11 by 3 minus 2 ones are 2 13s are minus 13. Here minus into minus plus 12. It is equal to 11 by 3 minus 1. It is equal to 11 minus 3 by 3. It's 8 by 3. This is the second one. Third one, in C3, x is equal to 0. From this dx equal to 0 and y limits from 1 to 0. Okay. Here integral over C3 Mdx plus Ndy is equal to integral C3. M is 3x square minus 8y square into dx plus 4y minus 6xy into dy. Dx part is 0, here x value is 0. So integral y limits from 1 to 0, 4y dy. Okay. Okay. It is equal to 4 into y integration is y square by 2. Limits from 1 to 0, 2 ones are 2 twos are 2 into 0 minus 1. It is equal to minus 2. This is equation 3. Integral over C Mdx plus Ndy is equal to 1 plus 2 plus 3. The first value is, what is the first value? It's minus 2, 8 by 3 plus 1.
1.
1 plus 1 plus 8 by 3 minus 2. It is equal to 8 by 3 minus 1. It is 8 minus 3 by 3 equal to 5 by 3. Therefore, integral over C Mdx plus Ndy is equal to 5 by 3 is equal to double integral over region capital R dou n by dou x minus dou m by dou y into dx dy is also 5 by 3. Hence, Green's theorem verified. Okay.